Hey, Jaden, Mr. Kilburn here. So I'm going to pick up where we left off with sums. Again, this was the formula for right end, and the formula for left end is going to look similar, but just a little bit different. So for the left end, it's going to be the width of those rectangles, which is 2/5, times I minus 1. Okay, and the reason for the minus 1 is because we want this to butt up against the x-axis. All right, so if it's the first index, 1 minus 1 is 0. We want it to start right there. Okay, alrighty then. So the width, this will end up being the height. And the width, again, delta x, is the upper bound minus the lower bound divided by n, which in this case is 2 minus 0, again, over 5, because there's 5 rectangles, which makes it 2/5. Okay, so here we go. So again, the sum from I equals 1 to 5 of, in this case, f of, if I distribute this 2/5, I get 2i minus 2 over 5 times 2/5. Again, this is the height, and this is the width. Okay, so I'm going to plug in that 2i minus 2 into the function. So you're going to get really good at writing these summations from I equals 1 to 5 of, so where I see that x right there, I'm plugging in the 2i minus 2 over 5 and evaluating it. So negative 2i minus 2 over 5 squared plus 5, and then all of that times the width. And now it's just a matter of evaluating this from I equals 1 to 5. Squaring 2i minus 2 over 5. Again, you would FOIL it off to the side, okay, but I'll save you a little bit of writing here. So 4i squared minus 8i plus 4 all over 25 plus 5 times 2/5. And this is definitely tedious, no doubt about it, but it is what it is. Okay, so at this point, you'd probably want to distribute the 2/5. Multiply it here and multiply it here. All right, so you would get 8i squared minus 16i over, or plus 8. So multiply across the top, and then in the bottom, 25 times 5 is 125. And 2/5 times 5 would be plus 2. Okay, so what I'm going to do now is, when you're doing summations and sums, you factor out constants when you can, all right? So if you notice, there's powers of 8 on top, okay, and a 125 on the bottom. So I'm actually going to factor out negative 8 over 125. And I'm going to write this as some different sums right here. So the sum from I equals 1 to 5 of I squared minus 2 times the sum from I equals 1 to 5 of just I. And the reason it's 2, because 8 times 2 is 16. So this is where factoring, super important. Plus the sum, oops, that's a pretty bad one. I equals 1 to 5 of just 1. And then, plus I'm going to have to squish this in here. I'm running out of space, as you can see. And sometimes I struggle writing these dumb things too. I equals 1 to 5 of just 2. Okay, keeping this out here. I'm going to replace the I squared with that summation formula, which is 2n cubed plus 3n squared plus n over 6 plus 2 times n squared plus n over 2 plus one of those summation formulas. If there's just a constant here, you multiply it by the upper bound. So 1 times 5 is 5, and same thing here. 2 times 5 is 10. Okay. So now, you got to be really careful with your calculator. Maybe you want to break it up into parts, but the n stands for the number of rectangles, which is 5. Okay, so now I'm going to plug a 5 in. And rather than, I'm running out of space here, so plug a 5 in wherever you see an n. You just got to be careful. But so for right here, you end up with 330 over 6. Minus 30 plus 5 plus that 10. And when you do that, you in fact get that 8.08. So the takeaway here really is our estimation here was low, right? Because we did the right end to start, so you had all these gaps here. And the left end one, which we just did, is kind of high because it's not inscribed, it's circumscribed. So you've got gaps above where the actual curve is. It's an overestimation. So then obviously it's the case that the area is between 6.48 and 8.8. And if you look down here, if we were to do, say, 25 rectangles, you're going to get a much closer approximation. And if you did 100 rectangles, it might go from, I don't know, I'm just kind of guesstimating here, but let's just say it's 7.2, between 7.28 and 7.34 or whatever. And then 1,000 rectangles and so on. Okay. Okay. So hopefully, like, you paused as much as you need to. I know it's a lot. It's just, it's a matter of getting used to factoring out constants and substituting in summation formulas and making it look good. Okay. So finding area by limit definition. I kind of jumped ahead a little bit and gave you this formula earlier just to, I don't know, try to make things a little simpler to start. But even though it's faint on your notes, all right, you can see here that there's A is the lower bound, B is the upper bound, and it's talking about, not just 5 rectangles or 10 rectangles, an infinite number of rectangles. And as you do that, you get the exact area under the curve. So the width is always going to be the upper bound minus the lower bound divided by n. And again, n is arbitrarily large. Okay, when we're doing our limits, or the limit as x approaches infinity, well, you can think of this as the limit as n approaches infinity. Same kind of idea. And all this is saying is, down in here, with enough rectangles, meaning an infinite number, the lower sum and the upper sum are going to eventually equal one another. So as the number of rectangles that are inscribed is increased, and the number of rectangles that are circumscribed increase, you get the area of the region. Okay, that's all. So rather than get bogged down in too much notation there, that's what that's saying. Eventually, with enough rectangles, the lower sum is going to equal the upper sum. So that's what that's saying. Okay, so I know this is probably I should have maybe deleted this first before having you, so you don't have a panic attack. Hopefully you're enjoying your vacation. Okay, so we'll do one more here, and then it'll probably be a long enough video for you to watch. It'll be, I'm sure, a little on the painful side. Okay, so this time we'll start with the left end, and then we'll do the right end. Make a little divider here. Okay. Okay, so we'll start with the left end. Okay, so the index what's called where the rectangle hits the function. Okay, c sub I is the lower bound plus the index times the width. All right, so the width, delta x, is upper bound minus lower bound, upper bound minus lower bound divided by n. Okay, because it doesn't say, I mean, I see that there's 4 rectangles there, but we're going to figure out the exact area under the curve. All right, so in this case, the lower bound is 0, the upper bound is 2. So 2 minus 0 divided by n, which means the width is going to be 2 over n. All right, and the left end is going to be given by 2, well, 0 plus, so c sub I, the lower bound is 0, plus I minus 1, 2 times I minus 1, over n, which is 2I minus 2 over n. Okay, again, the minus 1 is going to be so it snugs up against, in this case, the x-axis. It doesn't have to be the x-axis or y-axis. It doesn't have to be the y-axis. It could be wherever the lower bound is. Okay, so in this case, notice our function is simply y equals x squared. So it's kind of a simple function, right? Just a parabola. So all of our summations, though, in this case, are going to look like I equals 1 to n, because we don't know what n is. It's just some number. Okay? So, here we go. So f of 2I minus 2 over n squared times 2 over n Are you done, Avery?
Yeah, I missed the passing point by 2.
It said you should take 30 to 40 minutes.
Hmm?
Did you rush through it?
No.
Okay.
I got 38. That's in the school.
Did you get 39 last time? Oh my gosh. You'll get there, sweetie.
I'm gonna cry.
You're fine. Okay, you'll get there. Okay, sorry, Jaden. Okay, so here we go. Sorry about that. I equals 1 to n of 2I minus 2 over n squared times 2 over n. Square that. I equals 1 to n. So 4I squared minus 4 over n squared. Oh, no, hang on. No. 4I squared minus 8n, minus 8I, good grief, plus 4 over n squared times 2 over n. I equals 1 to n. Distribute that 2 over n, so that'd give you 8I squared minus 16I plus 8 over n squared. Okay, n cubed, because n times n squared is n cubed. Okay, so all I did is distribute this 2 over n to everything inside there. Okay, now if you notice, I can factor out an 8 over n cubed. Again, n is just a constant. So 8 over n cubed is coming out. All right, and I can rewrite that as the sum from I equals 1 to n of I squared minus 2I plus 1. Moving forward, 8 over n cubed. Why don't we write these estimations just because we're still new at this. So the sum from I equals 1 to n of I squared minus, bring that constant out, that 2, minus 2 times the sum from I equals 1 to n of just I, plus the sum of I equals 1 to n of 1. Okay, that's 8 over n cubed, just keeps coming along for the ride. Now I'm going to substitute a summation formula, in this case for I squared. So that's 2n cubed plus 3n squared plus n all over 6 minus 2 times the summation formula for I, which is n squared plus n over 2, plus the sum from I equals 1 to n of just 1 is 1, that constant times the upper bound. 1 times n is just n. Okay, so now, so now let's distribute this 8 over n cubed. Okay, so follow along. What I'm going to do, Jaden, is this. I'm going to multiply 8 times 2, and then 8 times 2 is 16 n cubed, all over 6n cubed. Okay, so just all I'm doing is distributing right now. Okay, so follow along. So 8 times 2n cubed is 16n cubed over this 6n cubed. All right, plus, because of that plus, 24n squared over 6n cubed, because of the 8 times 3, plus 8n over 6n cubed. Okay, minus. So I'm doing a couple things at once here. So 8 times 2 is 16. So I'll have 16n squared over 2 times n cubed is 2n cubed, minus 8 times 2 times n, 8 times 2 times n. Let me erase this a little bit here so maybe you can see a little better. Boom, plump. 8 times 2 times n is 16n over n cubed times 2, which is 2n cubed. And then 8 over n cubed times n would be plus 8n over n cubed. Okay, now, go back to your limits brain for a second. First of all, n cubed divided by n cubed, they canceled, and this reduces to 8/3. Plus, well, 2 of these n's cancel out 2 of these n's, but I'm left with 24 over 6n. And remember, 6n, n gets arbitrarily large. So 24 over 6n actually becomes 0. Same thing here. N here, that becomes n squared. The bottom gets arbitrarily large. Same thing here. Those 2 n's cancel 2 of those n's, but there's still an n there. So I'm left with a 0. Minus, that n cancels out one of those n's. I get 16 over 2n squared. So n's going to get arbitrarily large. That becomes 0. This n gets rid of one of these n's. So I've got 8 over n squared. That becomes arbitrarily large. So after all that, the area is 8/3. Okay, now I'm going to try to write fast here. My Apple Pencil is about to die. I should have checked it before I started this, but I didn't. Okay, so here, delta x, again, is upper bound minus lower bound divided by n, which is 2 over n. The right end is what we normally use going forward. I'm showing the left and the right here just to make a point. But going forward, normally we'll just use the right end because it's a little simpler to write. So it's the lower bound plus I times the width, which in this case is 0 plus I times the width, which is 2 over n. So the right end is simply 2i over n, rather than 2i minus 2 over n. A little simpler to work with. Not a huge deal, but okay. So here we go. The sum from I equals 1 to n of 2i over n squared times 2 over n. Again, this gives you the height and this gives you the width of each of the rectangles. When I square that, I equals 1 to n, I get 4i squared over n squared times 2 over n. This gives me I equals 1 to n, 8i squared over n cubed. Now, 8 and n cubed can get factored out and brought outside. And I'm left with just I squared. Okay, which actually makes life a little bit easier. Because when I use my summation formula now, and for I squared, again, is 2n cubed plus 3n squared plus n over 6. I'm back to just distributing. Okay, 16n cubed over 6n cubed. Again, just doing this, and then each of these are going to be over 6n cubed. Plus 24n squared over 6n cubed plus 8n over 6n cubed. Well, look what happens here. Those n cubes cancel. 16 over 6 reduces to 8/3. Here, n squareds cancel. I'm left with just n. 24 over 6n. That n grows arbitrarily large, so that approaches 0. And then the same thing here. N cancels. I'm down to n squared on the bottom, but 8 over 6n squared, 6n squared is going to get arbitrarily large because, again, n is the number of rectangles. So I need the exact area under the curve. If I take 600 bagoogle rectangles, 8 divided by 600 bagoogle is going to be basically 0. And obviously, as it approaches infinity, it really is going to be 0. So I get another 0 there. And look what happens. I get 8/3 again. So how did I get 8/3 again? Because as the previous page was just talking about, when you take an infinite number of rectangles to get the area under curve, whether you do the left end or the right end, as n approaches infinity, the exact area of the curve is going to appear. So whether you do left, you're going to get 8/3, or whether you do right, you're going to get 8/3. Okay, let's stop there. I'll get this shared out to you. Hope you have a good vacation, and we'll just pick up where we left off. Let me see here. How much more is there? There's a couple more problems. So for right now, Jaden, just try doing 6 through 16 is just kind of like practice with summation notation. It's not really getting area under a curve. Well, I said 6 through 16, sorry. 6, 12, 14, 16. Try doing those. And try 48. Try those 5. And then we'll pick up where you left off when you get back. Okay, see you soon, Jaden. Take care. Bye-bye.